Okay guys, we've been exploring this idea of a mathematical sequence, and so this list of numbers that occurs in order. So far we've talked about some vocabulary, and so these sequences all have terms, and these terms occur in a certain position. We've seen that we can use a rule to find the value of a term in a given position. In this video we're going to look at maybe graphing our sequences. And so the neat thing about graphing a sequence is very much like graphing a function. If we have a set of points, we can go ahead and graph them. The thing that's going to be slightly different this time is that instead of having an x and a y, what we tend to have is an n, or a position value here, so position, and then we have a sub n, or f of n here, which represents our term value. So with respect to graphing a sequence here, instead of having our traditional x and y axes, let's go ahead and label these here. We're going to say that this is our n axis here, and this represents our position, okay? And that our y-axis is going to serve as our f of n axis, which serves really as our term value. So we can see that we're plotting the value of this term at a given position. Now, one thing that's pretty neat about this is that when we talk about sequences, for instance, this first one we see here, -1, -8, -27, -24, we only gave the first 4 terms of this sequence. And so it's the first 4 terms we're going to graph here, and they each have values of -1, -8, -27, -64 respectively. But for what it is worth, the thing with sequences is we're always going to start at the first term, which means that with respect to our x-axis, we tend to only graph dots for these x values that occur to the right of the origin here, because we're only ever going to have term values that occur at a position of 1 or greater. Now, in terms of the y-axis, now that really depends. Looking at our outputs here, I notice that they are all negative. So am I going to need above and below the x-axis, both positive and negative y values? Yes, and that's the case. Term values here, or sequence values of their terms, sequence term values, they can be positive or negative. And so we're going to want to be open to being able to graph above or below the x-axis. In this case here, I am going to change the scale on my y-axis so that I can fit this a little more easily. But I feel that if I go by tens here, I'd be able to fit all of these points on. And so what we're going to do here is this. We're going to graph the first 4 terms of this sequence. And so that involves us graphing at 1, 2, 3, 4 here. 1, 2, 3, 4, 5. I'm just going to mark this with a -50, and we'll go up 1, 2, 3, 4, 5. Somewhere we have to determine the scale for our audience. So graphing this, what would this look like? Well, I'm actually going to switch out colors. Let's go with a green here. And so we say our first term is at 1, -1. In other words, if we go to position number 1 here, our term value is -1, which almost, if we're going by tens, looks like it's on the x-axis. If we're at our second term, it has a position of -8, or position of 2, a value of -8. 3, so the third term has a value of -27, so that'd be down about 2.7 notch marks if we're going by tens. And then down 6.4 notch marks in the fourth position here, so we say 50, 64. You start to see this right here. Now, if we were to keep going to the right, what you're actually going to see is, functionally, if this were a function, an exponential growth function. It grows to be negative and has an asymptote on the x-axis. But here, what you see is a series of 4 dots. So I really have to ask this question here, should we connect the dots? Do you think we should? And so to answer that question, I'm going to go ahead and just connect the dots here with this series of points. If you connect the dots, then what that means is that there was a term that was in the 2.5th position and had a value that was somewhere between -8 and -27. So is there a term that's in the 2.5th position? Well, this is kind of like when you look at a sequence of numbers, you have a first number, a second number, a third number. There is no term that occurs between the second and third term, or no values that occur between any 2 given consecutive terms. So one thing that needs to be said is this. When it comes to a sequence, we simply do not connect the dots, and we have to give a reason why. So do not connect the dots on the graph of a sequence. This is because no terms occur between any 2 given positions in the sequence. So that is to say, you only ever have terms at whole number positions here. Okay, so let's take a look at maybe graphing one more of these here. We had two graphs on the previous example there. This graph here was 0, 2, 6, and 12. You know, I'm going to give you the same advice that we did last time, which is we're simply going to put this into a table and graph it like we would a function here. So we're going to say n, and I'm going to say, how about b sub n here? Our first, second, third, and fourth terms had values respectively of 0, 2, 6, and 12. So again, when we label this out, we have to decide what we want our scale to be on each of these axes. But we have n and we have b sub n here, where this is a 5. And I don't think we're going to need to change our y scale too much here. We might be able to fit this on. So we say our first term has a value of 0. So we're going to put that right here. Our second term has a value of 2. Our third term has a value of 6, so 2, 4, 6. And our fourth term has a value of 12, so 6, 7, 8, 9, 10, 11, 12. It'd be kind of up here. You can see that this almost looks like a half of a parabola here, a quadratic. But these would be the values of our terms and their positions. So when it comes to reading these graphs, we also might receive the terms of a value, not in a table, but not in roster notation, but it's a graph. And we just want to read this as the value of our first, second, third, and fourth terms respectively are 0, 2, 6, and 12. Okay? So graphing sequences, a lot like graphing functions. As a matter of fact, it's basically the same thing.